In this video, we're going to talk a little bit more about blood pressure and how blood pressure is regulated. So first of all, let's just define what blood pressure is. And so if we think about a blood vessel, so these are the walls of a blood vessel, and you have this fluid, this blood moving through this blood vessel. If the blood vessel is full of blood, you also have blood that is exerting pressure against the inner walls of the blood vessel. And so that is what we know as blood pressure. And blood pressure is one of those things that has to be kept in homeostasis. So we need to have a certain amount of blood pressure to keep blood moving through our body. So if our blood pressure gets too low, there's not enough pressure to get it to all the different blood vessels in our body. And for example, if the blood can't get to the brain, then the brain doesn't get the oxygen and nutrients it needs, and you pass out. Now, if blood pressure is too high, that can also be a problem because it can put excess strain on the blood vessel. So imagine these blood vessels, over time with this pressure, they might start to bulge out, and that might make the walls kind of thinner. And ultimately, what could happen is the wall of the blood vessel could break, and then you could have an aneurysm, basically that burst, and then now you've got a problem with internal bleeding. If you've ever gone to the doctor and they've taken your blood pressure, they usually tell you two numbers. So normal human blood pressure is 120/80. And what this means is this is actually a number that refers to the systolic pressure over the diastolic pressure. And the systolic pressure is the pressure exerted on the blood vessel walls when the heart is beating. And diastolic is the pressure exerted on the inside of the blood vessel walls when the heart is at rest. So if you think about a pulse, so if you've ever taken your pulse on your wrist or maybe in your neck, you can feel those pulses of blood moving through your arteries as the heart is contracting. So each time the heart contracts, it kind of sends out this pressure wave, and you get that kind of expansion of the blood vessels that you can actually feel, and we call that the pulse. And so the systolic pressure would be when the pulse is happening. So when that heart is beating and that pressure wave is getting pushed through the blood vessels. Diastolic is when the heart is not beating or in between beats, when the blood vessel is just kind of at its normal pressure amount. And as I mentioned, normal human blood pressure is considered 120/80, but just like anything with homeostasis, there is typically a variation around that is still considered healthy or acceptable. And the units here, millimeters of mercury, this is just a pressure unit. So blood pressure in the body is controlled by cardiac output. And so cardiac output can be calculated by looking at the stroke volume multiplied by the heart rate. So the definition of cardiac output is the volume of blood pumped by the heart in 1 minute. And like I said, we can take the stroke volume, multiply it by the heart rate. So stroke volume just refers to the volume of blood pumped into the aorta per contraction of the left ventricle. So basically the amount of blood that the heart is squeezing out of the heart into the aorta with each heartbeat. And heart rate is the number of heart contractions that occur over 1 minute. So blood pressure can be altered by anything that alters the cardiac output. So changing the stroke volume and changing the heart rate can both change the blood pressure. So looking at this, so an increased stroke volume would give you an increase in blood pressure. So essentially, your heart can do stronger contractions, and it can pump more blood out of your heart with each contraction because you're your heart is pushing on the blood harder. It can also be due to faster blood movement. So the blood vessels in your body, so kind of systemically, they can go through vasodilation or vasoconstriction. Now, your body can also do vasoconstriction and vasodilation in kind of just localized specific areas of the body, but then it can also happen kind of all over the body. So if vasodilation happens systemically all over the body, there's less resistance, which means that more blood returns to the heart, which means that the heart can then push more blood out of it. Increased heart rate can also increase blood pressure. So if you think about the things that make your heart rate increase, so think about being scared or if you are exercising. These are all things that can increase your heart rate. Now, the things that can affect stroke volume and heart rate are going to be things like neurotransmitters and hormones. And so these are the messengers that can change your heart rate or change the stroke volume. And these are just some examples. So epinephrine and norepinephrine. So epinephrine is also known as adrenaline. So think of your fight or flight response of the sympathetic division of the autonomic nervous system. When you are stressed, epinephrine is released, which can increase your heart rate and increase the strength of your contractions. Hormones like cortisol. So cortisol is also associated with stressful events. Thyroid hormones can also increase your heart rate or your stroke volume. And so your thyroid hormones generally increase your metabolic rate. Now, there are other neurotransmitters and hormones that are also associated with this, but these are just some common examples that some people kind of already know about.